What's up, class? Let's look at section 7.3, logarithms. And hopefully you already looked at the GeoGebra thing and saw that it was pretty cool and kind of get an idea of what this is. This is an inverse of the exponential. So log, let me spell this before I forget. L-O-G-A-R-I-T-H-M-S. Logarithms. Man, I wish I had done better writing that word out. Section 7.3, but let's go ahead and do some stuff. So, basically, a logarithm is the inverse of an exponent. So if I write an expression with an exponent, we'll call this exponential form. And exponential form would be something like 2 to the 5th power equals 32. Or it might be 32 equals 2 to the 5th power, whatever. That could be in the opposite order. But regardless, when I change this to logarithmic form, what I do first is I write the word log, and you can see that button on the front of your calculator. Oh, it looks like log. And then next is the base. The base is 2, so the base is 2. The power comes next, 32, equals 5. So the exponent goes over here. So really, visually, what you see is a switch between the exponent and the power. Instead of 5 and then 32, it's 32 and then 5. And that's what this logarithm means. It's the inverse of the exponent. It switches the x and the y. Switches the x and the y. Okay, so you might end up with a question like, what is log base 2 of 8? What is log base 2 of 8? Question marks. Okay, the question you need to ask yourself in your head is this, because we're not used to thinking in logarithms, but we are used to thinking in exponents. So we're going to rethink this question as an exponent. Okay, so I'm going to say 2 to what power is 8? So when I see this question, I switch it to an exponent. I think 2 to what power would give me 8? Or 2 multiplied by itself how many times will give me 8? Well, that's 2 times 2 times 2. And that will give you 8. So the answer is 3. 2 to the 3rd power gives you 8. So log base 2 of 8 gives you 3. Finally, I want to look at the graphs of logarithms. I guess I could put a line there and a line here. Kind of separate that stuff out. So, y equals log base b, base b of x. Ignore the squiggly. Y equals log base b of x. And let's see what this graph would look like. You're always going to have, I'll make it kind of big. This is the last thing I'm going to put here. You're always going to have the point 1, 0. And you're always going to have the point b, 1. Okay, so whatever your base is, it's going to go through the point b1. This was like the point 1 something with the exponent. Switch them around, b1. And this point right here. And this will get always closer to the y-axis. The exponential always got close to the x-axis but never touched. This always gets closer to the y-axis but never touches. And then through that other point. This always grows up, but it's very slowly. It always gets higher, but very, 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 very slowly. Okay, last thing I want to know is domain and range. The domain, well, the x-coordinates are greater than 0. Okay, they get very close to the y-axis, but they never touch it. So x never actually gets to 0, and they go up. The range, this graph goes down and up, positive in both directions. So all real numbers. And those are your notes on section 7.3, logarithms.